Welcome. This short video is an introduction to my latest project. The Amatrol Pegasus is a training robot, used by colleges and technical schools. It normally comes with a custom controller PC, and teach pendant, or wired remote control. About 9 months ago, I bought one off eBay, without the controller PC and teach pendant. I built my own control system, and use an 18-year-old iMac to send it commands and receive back telemetry. Here you can see the robot homing itself. It does this to have a point of origin, a reference location for all movement. Once the robot homes itself, it is able to receive commands from the PC. The robot uses a differential drive in the wrist joint. When one motor is used, the wrist both twists and flexes, like this. Here is where homing the robot comes in handy. The other motor on the wrist joint works the same way, only in the opposite direction. When both motors are run in the same direction, they rotate the wrist. Running them in opposite directions would flex the wrist. The manipulator operates much like a scissor jack, in order to open and close. The elbow joint is chain-driven directly off the gearhead motor. This causes gravity to affect the joint, making it difficult to hold stationary. The shoulder joint is driven from a worm gear, as is the base rotation, so these joints do not have the same problem. The Amatrol Pegasus uses 6 gearhead motors, commonly called Pitman motors, after the primary manufacturer. These custom motors consist of the motor section, here. The gear reduction, which in this case, is 19.7 to 1. And finally, a 512 count per revolution rotary encoder. This motor, which I numbered 1, drives the base rotation through a worm gear drive. Motor 2 drives the shoulder joint chain, also through a worm gear, which is inside the box that the motor mounts to. Motor 3 drives the elbow joint chain directly. Motor 4 drives the right side of the wrist. And motor 5 drives the left side of the wrist. Finally, motor 6 operates the manipulator. In addition to the 6 rotary encoders, the arm contains 5 home sensors. These are Honeywell transmissive sensors. A small pin mounted to the moving part of the joint interferes with the light between an infrared emitting diode and a phototransistor when the joint is in the home position. In addition to a difficult-to-see sensor on the rotating base, there is this one on the shoulder joint. This one on the elbow joint. The green square here is the back of the one for the left part of the wrist drive. The sensor for the right side of the wrist drive is under this black cover, and is actually a slightly different style. The manipulator does not have a home sensor, and is assumed to be closed when the arm is homed. Thank you for watching this video, and I hope that you enjoyed it. With a lot of work, and months of time invested, you too can move a small block of wood across a table.